the statements will read something like that. Y varies inversely as X. This is one way in which an inverse variation is stated. Varies inversely. Or, equivalently, we can say Y is inversely proportional to X. Now, both of these statements mean exactly the same. And the way we write an inverse variation is this. Y varies. Directly means multiply by the variable, k by the variable. Inversely means divide. That's an inverse variation. If you think about it, right, you have a constant right here that's been divided by x. What happens to a fraction when the numerator stays the same and the denominator gets bigger? For instance, imagine you have one cake and one person shows up. Well, then you get the whole cake for one person. If 2 people show up, they get half. And if 3 people show up, and if 10 people show up, at 10. What's happening to the amount?
Smaller.
So the larger x gets here, what happens to y? It gets smaller. The piece gets smaller. This is what we call an inverse variation. In the previous examples, when x got larger, y got larger. Here, as one variable increases, the other one is going to decrease. So this is one way to write the equation. The other way is if you multiply by x both sides of the equation. An inverse variation is one in which the product of the 2 variables never changes. So we can say y varies inversely as x this way, or we can say, look, xy is constant, meaning if the product of 2 variables is the same, always, then those variables are inversely proportional to each other. Okay? So an example here. P is inversely proportional to Q. When Q equals 2/3 P is equal to 6. Find P when Q is 2. Exactly the same problem as before. The only difference is you have a slightly different equation to solve. It's up to you which one you want to write first, but for inverse, I always think of this. I gotta divide. I'll write my equation this way. P is inversely proportional. I immediately know I'm going to divide to what? Inversely proportional to?
Q.
And now I'm going to plug in the values of P and Q that I will be given to solve for K. What do I plug in right here?
6.
6 equals
K.
K over, what's Q?
2/3.
2/3. All right, not the prettiest thing we've ever seen, but that's okay. We know how to solve for k. We're going to multiply both sides of the equation by whatever's in the denominator, which is 2/3. Multiply by 2/3 here. Multiply by 2/3 right here. 2/3 cancel out. If I put a 1 right here, what do I get for k? I can reduce my fraction first. 3 goes into 3 once. 3 goes into 6 twice. 2 times 2 is 4. Again, I can take this k and plug it right in here, and here's what I get. P is equal to k over, I'm so sorry, not k.
4.
4 over
Q.
Q. That's my equation. And now, I can go ahead and find P when Q equals 2. See, it's a matter, when you're doing variation problems, find K, and that'll give you an equation, typically a fairly easy equation to solve, that will give you, that where you just need to plug in one of the two variables, and then you'll have the value of the other one. So where am I going to put in this 2? In place of which variable?
K.
Q.
Oh,
In
Q,
place
Q.
of Q, right? When Q is 2. So P is going to equal 4 divided by
2.
2. So what is P?
2.
2. So notice here, right? What happened to Q? Did Q get larger or smaller? It went from 2/3 to 2. That it got larger. What happened to P? It went from 6 to 2. What happened to P? It's got smaller. So we expected as Q grows, P is going to decrease because they're inversely proportional to each other. So examples of inverse proportion. Inverse proportion might be what I was telling you about, you know, the magnets. The force between the magnets, as the distance gets larger, the amount of force between them, the pull between them decreases. That should make sense to you. You put them further apart, there's little force. But if the distance decreases, if the distance between them gets smaller, what happens to the force? It increases, they pull harder, right? Another example of inverse variation may be, you know, suppose that we had to paint this room. And we let N be the number of painters, of workers painting the room, and T be the amount of time it takes to complete the job. Would you expect T and N to be directly proportional or inversely proportional? Inversely, right? Why? Because as the number of workers goes up, what happens to the amount of time?
Less time.
It goes down, right? Again, you would bring a very good point like terminal velocity. At some point, this breaks down, right? If I brought 150 people in here to paint the room, it's if we couldn't get anything done, it'd be just chaos. But in general, you know, under some constraints, the more workers you bring in to do the job, the amount of time required is gonna go down in ideal situations.
So the way I understand it is like where one situation affects the other and vice versa, right?
That's variation. Now the question is how they affect each other. If it's a situation where if you increase one variable, the other one increases, what kind of variation is that? If I increase one, the other one goes up as well. We call that what?
Well, that wouldn't be variation. That would be
No, it's a variation, but it's which kind?
I mean-
Direct or inverse?
direct.
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 One goes up, the other one goes up. Direct variation. Now, if I have a variation where increasing one decreases the other, they're
That's
inverse. They go kind of like in opposite directions, right? That's what I want you to get out of this expression. Let's just